Hey AP Stats students, this is 7.2. So in 7.1, we learned about sampling distributions as a whole. Now we're going to specifically look at the sampling distributions of sample proportions. Let's say that of all the students in Franklin Heights High School, 42% agree with the statement, Miss Warthen laughs too loudly. Is this a P or a P hat? Well, it's a P because this is all the students at Franklin Heights, everybody in our population. Now imagine we take a random sample of 10 students and ask them if they agree with the statement. What might that sample look like? We could get 0 out of 10 that agree, 1 out of 10, 2 out of 10, could look like any of that. Maybe since 42%, maybe we would get something more like 4 out of 10 or 5 out of 10 students, maybe even 3 out of 10. Those would all be likely. Now, what if we took every possible sample of 10 students and measured the percent p hat of the students who agree with the statement in each sample? What would that distribution look like? We're going to open this applet. So we have our population proportion of 0.42 and our sample size of 10. So if we take one sample, well, there we go. So this was 4 successes and 6 failures, so 4 out of 10. We could draw another. And this one was 0.3, so 3 successes. And we could keep going. But now let's take more and more and more. So I'll take 10. And we can see the shape starting to form. So now I'm going to take 10,000 and get that. These are all p hats every time I take a sample. Now, remember, this sampling distribution is a theoretical thing. This is a simulated sampling distribution, but it's not perfect. But we see that nice shape that we've got going on here, the bell-shaped and a center around 0.42, which is the population, that orange. So that blue was our last sample, that last p hat, which was 2 out of 10.2. So the shape was bell-shaped symmetric. The center was about 0.42, and the spread, we didn't look that closely, but it was from 0 to 1, essentially. We choose a simple random sample of size n from a population of size capital N with a proportion of p successes. Let p hat be the sample proportion of successes. So that's exactly what we just did. N is all the students at our school. Little n was our sample of size 10. P was 0.42 in our example, and our p hat was all those different things, every p hat. That last p hat we had was 0.2. The mean of the sampling distribution of p hat is p, right here. The mean of all of these p hats is going to be 0.42, that orange. That's why it's right in the center of my simulated sampling distribution. And remember, when we take the mean of all of those samples, it should be the balance point, which is right in the middle. The standard deviation of the sampling distribution of p hat is p1 minus p over n. This is a formula we can use, but we can only use it as long as the 10% condition for independence is satisfied, meaning our sample size n is less than 10% of big N. So if we go back to our example, big N is all the students at Franklin Heights, so about, let's say, 1350. Our sample size N was 10, and 10 is definitely less than 10%, right? 1/10 of this, 10%, 1/10, same thing. 1/10 of that would be 135. So I could take up to a sample size of 135 for my N and still be okay to use this formula. So find the mean and the standard deviation of the sampling distribution. Well, the mean of the p hats was 0.42. The standard deviation, sigma of p hat, is 0.42 times 1 minus 0.42 all over 10 and square rooted. So 0.156. What would happen to the sample had 40 students? Well, let's think about this real quick. If we had a bigger sample size, remember that shrinks our standard deviation. It's going to make our sampling distribution skinnier. So if we use our standard deviation formula, now we have 0.42 times 1 minus 0.42 over 40. Well, now we're dividing by 40 instead of 10. But if we think about that square root, it's really, instead of 4 times smaller, it's really 2 times smaller. So it's going to be half as large. So let's see what that does. You see how my sampling distribution is about half as wide? It used to be almost the whole thing. The sampling distribution of p hat seems to be approximately normal some of the time. What conditions make this happen? Well, we've talked about these conditions before in the binomial chapter. We said NP needs to be greater than or equal to 10, and n times 1 minus p should be greater than or equal to 10. We call this the normal condition. About 75% of young adult internet users ages 18 to 29 watch online video. Suppose that a sample survey contacts an SRS of 1,000 young adult internet users and calculates the proportion p hat in the sample who watch online video. What is the mean of the sampling distribution of p hat? And explain. This is the population p. Remember, so the mean of the sampling distribution p hat is p, so 0.75. Find the standard deviation of the sampling distribution of p hat. And we need to check that the 10% condition. So we can't do this until we check this 10%. The simple random sample is of 1,000, so n equals 1,000. So 1,000 is less than 10% of all young adult internet users. Now, we don't have an exact number, but there's plenty. There's so many young adult internet users that we're not violating this condition with 1,000, so we don't have to worry about that, and so we check the 10% condition. So then this sigma of p hat is 0.75 times 1 minus 0.75, which is 0.25 if you want to be specific, over 1,000, all square rooted. I just showed you how to use your calculator. It's not that hard. You guys can do it. Is the sampling distribution of p hat approximately normal? So we need to check that this normal condition is met. So remember, NP and N1 minus p are both greater than or equal to 10. Well, 1,000 times 0.75 and 1,000 times 0.25 are both greater than or equal to 10. We don't need to actually check this on our calculator. We know it's going to happen, right? Because 100 times 75 would be 75. So this would be 750 and this would be 250. Definitely greater than or equal to 10. So because the normal condition is met, the sampling distribution p hat is approximately normal. If the sample size were 9,000 rather than 1,000, how would this change the sampling distribution of p hat? Well, remember, the larger the sample size, the smaller the standard deviation. So remember, the standard deviation of 1,000 is going to be this, but with the 9,000, it's going to be 9 times the sample size, but because we're dividing, it's 9 smaller. However, it's square root of 9, so it's actually going to be 1/3 as wide. So basically 1/3 skinnier. A polling organization asks an SRS of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students actually attend college within 50 miles of home. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? So first of all, we're going to check the normal condition. So NP and N times 1 minus P. Well, our N is 1500 and our P is 0.35. And 1500 times 1 minus 0.35, well, that's definitely going to be greater than or equal to 10. So we know that we have a normal distribution. What are mu and sigma of the sampling distribution of p hat? Well, mu of p hat will be 0.35, right? Because that's our population p. Sigma p hat will be 0.35, 1 minus 0.35 over 1,500, all square rooted. I'm actually going to find this because we need it. So 0.0123. Draw your distribution and write a probability statement. So remember drawing normal distributions? Doesn't have to be perfect. And then our values, going back up to our question, we want to know what is the probability that the random sample will give a result within 2 percentage points of this true value of that 0.35. So we're looking for the probability that the sample p hat, right, that's the sample, is between 0.33 and 0.37. That's 2 percentage points above and below. So we will have a p hat 0.37 and 0.33. So we're looking for this area, and we can find that. Menu, statistics, distributions, normal CDF, remember, cumulative, 0.33 to 0.37. 0.35 is our mu, and our sigma is 0.0123. So there's a 0.896, so 89.6% chance that our sample would be within 2 percentage points.